Okay, so we're on Journal 65. We're going to start us off with a puzzle here to get our brains warmed up. And this is actually a famous problem. So Gauss, who was a famous mathematician, also known as the Prince of Mathematics, and so he made quite a few discovered quite a few theorems in mathematics. But one of the most famous stories about him is that when he was a young boy in elementary school, so this is like the late 1700s, he often, most of the time in his class, he would get bored. And because he was bored in class, he often caused trouble. And so one day his math teacher was like, you know what, I'm going to try to keep this kid busy, so I'm going to assign him some work to do. So the teacher was like, okay, Gauss, today you are going to sum up all the digits from 1 to 100. In other words, he had to find the total amount of what you get after you add 1 through 100. So that's like 1 plus 2 plus 3 plus 4 all the way up to 100 and seeing what that total was. So he was summing up all the numbers from 1 to 100. And so in this case, he goes on to do this because he's like, Gauss is like, challenge accepted. I'm going to go add up all these numbers. But when he was adding the numbers, he realized that there was this pattern to the adding. And then when he realized there was this pattern, he was able to make a simple formula that allowed him to get to the answer faster. And so that's what I want you guys to try to figure out, is the pattern of what Gauss saw in the numbers when he was adding. So one thing to point you in the right direction of what Gauss might have saw was if he was looking at the numbers, so 1, 2, 3, so the digits between 1 to 100, I want you to not just look at the numbers in front and add it linearly. In other words, 1 plus 2 plus 3 plus 4. Don't do that. Think about how the numbers from the first 4 versus the last 4 digits. So that would be, let's see, 100, 99 if I were to go backwards, 98, and 97. So look at the numbers in the front of the beginning of 1 through 100 and look at some of the numbers in the last few digits of 100. And see if you notice a pattern when you're adding up the digits. So I'll give you a few minutes to try that out. So I would pause the video and try to figure out if you can see the pattern, and then come back and see the solution. All right, so now I'm going to show you what Gauss saw. So he noticed that when he took the first number, 1, and added it with the last number, 100, well, that gives you 101. But then he did it with the next inner term. So in other words, he was going to add the 2 with the 99, 2 plus 99, whoa, is also 101. 3 plus 98 is also 101. And then it would keep on repeating when you add the inner terms together. So if you paired up the numbers, you always get 101. So now the question is, if you want to find the sum of the numbers between 1 and 100, then how many pairs of 101s do you have? Well, in this case, because there are, when you're going from 1 to 100, there are 100 digits. So that means that if you have 100 digits, that means you have 50 pairs, right? Because you would take 100, and then you would divide it by 2 to get that 50. Now, we want to multiply this number by 101. In other words, if you add the first term with the last term. So the first term was 1, added with the last term, which is the 100th term. So we're going to try to build a formula for this. So this is going to be our sum formula that we're going to create. So like I said, 100 divided by 2 is going to give you 50. If you multiply that by 1 plus 100, which is 101, you get 5,050. So when you add up all the numbers from 1 to 100, you get this number here. So that was pretty fast of us to do. Instead of adding 1 through 100 several times until we got to the answer. That's a lot of work. I also want us to notice something here. What type of sequence is this sequence that I've written out? So if you look at the first part of the sequence here, how are the numbers increasing? Well, you're going from 1 to 2 to 3, so you're increasing by 1, or in other words, you're adding by 1 number each time. So what type of sequence is this if you're adding by a number, the same number every time? Well, we learned that adding and subtracting by the same number is a arithmetic sequence. I might have spelled arithmetic sequence wrong, but that's okay. So we're dealing with an arithmetic sequence, and we want to find the sum of arithmetic sequence. And so Gauss's idea here actually creates this nice formula that applies to all of arithmetic sequences. Now, in the next slide here, I'm going to show you a general formula for an arithmetic sequence when you want to sum it all up. So stay tuned for the next slide for that formula. All right, so we're going to take a look at arithmetic series. So a series, you might have remembered me talking about this in the, Journal 63. If you haven't watched that journal, I would watch that one there. I talk a little bit about series in that video. So looking at series, that's where we take a sequence and we add up the terms. So series add up the terms of a sequence and give you a sum. So if I have an arithmetic series, I'm actually working with a specific type of sequence, an arithmetic sequence, and I'm going to add up all the terms. So this formula here helps us do that without being adding them tediously, like one at a time. Instead, we just have to plug in a few things to get our sum. So this formula here helps us find the sum for a arithmetic sequence. Do not try to use this for a geometric sequence. It will fail. This formula here only works for arithmetic. The AN here represents our first term. Our A1 represents our first term. Our AN represents typically our nth term, but in this scenario, we use it to represent our last term. Okay? And then N here represents the number of terms that you want to add up. So if you notice that your term only has like 5 terms and you want to add them all up, then this N would be 5. So this is the number of terms in a sequence. I also want to mention this word finite. So finite just means that there is a stopping point in the sequence. So like if you have a sequence, let's say 1, 3, 5, and then 7. So this is a finite sequence because you can see here there are 4 terms and it stops at the 4th term. So like there's not numbers after the 7. So an infinite sequence or not a finite sequence is something that has like ... which means that it will continue to go beyond past the 7, but it's just not written. So that is what we call an infinite sequence because it never ends, or it's implying that it'll never end. Okay, let's take a look at the symbol for series. So we can represent a series using what we call a summation. So this E here, we can think of it in the Greek alphabet, it's called sigma. In mathematics, it's treated to symbolize the summing of terms or the summing of something. So adding up something. So this summation symbol has 3 components. It has a lower bound. So this I equals 1 is what we call the lower limit or lower bound, you could think of it too. And it represents our first term. Where does our first term start at? In this case, our first term starts at 1, so that means I have an A1. And then up here is going to be our last term, or our upper limit, which is our last term of the sequence. In this case, we're ending at the fifth term. And this middle part here is the formula if you want to get that number in the term. So let's say that you're starting at the first term. So if you want to know what A1 is, or the first term, you would plug 1 into the variable, in this case I, and calculate what that number is. So this middle component is your formula that essentially tells you the rule of the sequence. Okay, so we're going to find the sum of this series here. So to find the sum of a series, you need to use this formula to help you out, because if you don't use this formula, what you would have to do is sum up all the terms from 1 to 200. So remember, that what part here is your lower limit. So your first term starts at 1. So that means that if I want to know what the first term is, that's going to be A1. So since this is 1, I can start at A1. To figure out that value, I have to plug 1 into the formula, so in I. So that's going to be 2, plug in 1, plus 5, which is 7. So A1 is 7, or else, in other words, the first term is 7. Now I need to know what my last term is. So the upper limit tells me my last term. I'm going to be ending at the 200th term, so this is going to be A200. So I'm going to use the same formula here to get my term. I have to plug in 200 this time into I, though. And that gives me 405. All right, so I have the first term, I have the last term. Now I need how many n's there are. So if I'm going from 1 to 200, that means that there are 200 digits in my sequence, or 200 terms. Okay. Usually, just as a tip here, anytime this is like a variable equals 1, that means your upper limit is like how many n's or how many terms there are. Okay, so we got 3 of the ingredients. We got the first term, last term, and n. So all you have to do is plug it into the formula. So the formula says n over 2, so that's going to be 200 over 2. In parentheses, we have the first term, which is 7, added with the last term, which is 405. So if you divide 200 by 2, that's 100. If you take 7 and add it with 405, that's 412. If you multiply, this is 41. Okay, so this is going to be 41,200 as my final answer for the sum. So this here is our sum. Okay, so let's take a look at the next sequence. This one's a bit tricky because you'll notice here that the lower limit doesn't start at the first term. It starts at n equals 3, so in this case, the third term. Instead of plugging 1 into A, you're going to need to find A3, because that will lead you to what you should have in the first part of the sequence. So we're going to find A3. So that's just plugging 3 into the sequence. And so 2 times 3 minus 1 gives me 5. Now I want to find the last term, which is A10. So I'm going to take my upper limit and plug the 10 in for n. By the way, it doesn't matter whether you have n's or i's or whatever variable your heart desire, okay? You treat them just like how you would treat any other, like how we did it here. So this n, what we're using it for is to plug in our n values. So in this case, A10, if I plug in 10, 2, 10 minus 1 gives me 19. Okay, so I have my first term and my last term. Now it's a matter of figuring out my n, so how many terms are in this series. Well, because I start at 3 and then I go to 10, I'm going to actually have 8 terms in my sequence. Now, I got that really quickly, so I want to show you how you could find it. So if you just, a lot of people when they look at this here, 10 and 3, they think about subtracting them, which they're partially correct. If you subtract them, you get 7. However, the number of terms here in this sequence is actually 8, because oftentimes when you're counting up the terms, you want to count up the third term here, or whatever this lower one is. So count with your fingers. So you would have the third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term. When I count with my fingers, I actually have 8 fingers, so 8 terms. Now, if you don't want to do this by hand and counting your fingers, all you got to do is take the 10, subtract it with the 3, you get 7, but then always add 1 to your subtraction. So let me repeat that. If you subtract the upper bound with the lower bound, to find your n, you have to add 1 to it. Notice that you have a 200 here and a 1. If you subtract 200 from 1, you get 199, but you add 1 to it to get the n value, in this case 200. All right, so enough with that. We have our first 3 things, so the first term, the last term, and the n value. So I'm going to plug this into my formula. So that's going to be first term added with the last term. That's 4 if I divide, and 24 if I add the 5 and the 19. 4 times 24 gives me, I'm going to use my calculator here, 96. So 96 is our sum. All right, so in the next slide here, we're going to practice the skill a little bit more, but this time around, I'm not going to be having you sum up series. I'm going to have you sum up given a sequence. So in this problem here, I'm going to rewrite that formula that we saw a moment ago. So that's the sum formula. So that's n over 2. First term added with the second term, or not second term, the last term. And then I also want to bring back the formula for arithmetic sequences. So this is the formula that helps you find the rule for arithmetic sequences. So that's an equals the first term added with n minus 1 times d, which d is the common difference. So that represents the pattern which the arithmetic sequence is increasing by. So if I want to find the sum, and I'm given the n value, let's take a look here. So like the first term, the first part here, part A, you have to find the sum. So look, you're given a sequence, and it says n equals 25. So in this case, you can assume that you're going up to the 25th term. So remember, if you want to use the summation rule, you need the first term. So A1 here is going to be the first term in the sequence, which is 12. And our last term has to be A25, because the n here is to the 25th. But I don't know what that is, so I'm going to keep that as a question mark. Because notice the dot, dot, dot here, right? It doesn't go all the way up to the 25th term. It actually stops at the third term. They already gave us our n value, so this time around we don't need to calculate it. So our n value is the n equals 25, so we're going to use that. All right, so here's the problem. I don't have the last term, so how can I find A25? Well, I can find it by using the arithmetic sequence formula. So if I want the 25th term here, that means n is 25, so I'm going to be plugging in 25 for n. So I'm going to set up that formula here. So I'm going to find A25. A1 is 12, right? It takes an A1 first, so that was 12, plus n minus 1, so that's 25 minus 1, times d. Now, we didn't find d yet. So d here, let me write that up here, is your common difference. So what's the pattern in this sequence here? How is it increasing? So from 12 to 19, then 19 to 26. So it looks like it's adding by 7 every time. So if you're adding by 7, so that means that your common difference is 7. So if I'm working this out here, So it'll be 12 plus 25 minus 1 is 24 times 7. So if you do 24 times 7, that's going to give you 168 plus 12, which is 180. So for the 25th term, it's 180. So now that we have the first term, the last term, and n, we're going to use that summation rule here. So I'm going to do it here. So that's going to be n, which is 25 divided by 2. Our first term is 12. Our last term is 180. And I'm going to work this out here. So 25 divided by 2 is about 12.5. If I add up 12 with 180, I get 192. If I multiply 12.5 with 192, I get 2400 as my sum of the sequence. So in this case, oftentimes if you're given a sequence, you might not know what that last term is. You might have to write a rule and then plug in what the number is you're looking for, or the term is that you're looking for. So now let's try that last one here. The same thing, you have a sequence, and this time around you're going to the 16th term. So your first term here is that 3. So I'm going to grab that. Our last term is going to be 16, but I don't know what that is because they only stop at the third term. So now if I want to find A16, I'm going to have to use this formula here to find what A16 is. But before I can do that, I need a D value. So D, in this case, if I look at the pattern here, from 3 to -1 and -1 to -5, it looks like I'm subtracting by 4. So D here is -4. So now I'm going to try to find A16, or the 16th term. So that's going to be A, the first term, which is 3, added with n minus 1. So in this case, this is 16 for n, so I'm going to plug in 16 minus 1, and our D here is -4. We learned that if the D has a negative number, you might want to put parentheses around it so that you don't forget that you need to multiply it by -4 and not subtract by -4. All right, so now that I have things set up, I'm going to work this out. So 3 plus 16 minus 1 is 15 times -4. So 15 times -4 gives you -60. So we have 3 plus -60, which is -57. So in this case, my 16th term is -57. Now that I have all 3 ingredients, so the first term, last term, and the number of n's, I'm going to plug this into my sum formula, so this formula here, and find the sum of the sequence. So we have Sn is equal to the number of terms, which is 16 divided by 2. And then our first term is 3, and our last term is -57. So if I work this out, 16 divided by 2 gives me 8. 3 plus -57 is -54. If you take these two numbers and you multiply, you get -432. And so this here is my sum. So when I add up all 16 terms, I get -462. All right, that's it for this journal. Now I want you to try out problems on page 2 of packet 14.